Hello, in this video I want to look at polynomial division. So we're going to start off by looking at long division. In order to do this, I want to first remind you of how long division works if you're just working with integers. So I have a couple examples here. First, we're dividing 4 into 39,157. So when you're doing this, you might recall you work from left to right, and you'd first ask yourself, does 4 go into 3? And of course 4 does not go into 3. So then I start looking at more digits. 4 goes into 39 though. 4 goes into 39 9 times. 4 times 9 is 36. I write that down here. And then the next step is to subtract. 39 minus 36 will give me 3. Once I have that 3, I bring down my next number, 31. And now I ask myself, okay, how many times does 4 go into 31? 4 goes into 31 7 times. 4 times 7 is 28. 31 minus 28 also gives me a difference of 3, and I bring down the 5. Now I ask, how many times does 4 go into 35? 4 goes into 35 8 times. 4 times 8 is 32. Again, I subtract. 35 minus 32 gives me 3, and what I get is 37. So, one last division. 4 goes into 37 9 times, and I subtract 36, 9 times 4, and get a remainder of 1. Now, of course, at some point you're taught to do long division, extending this to get a decimal approximation. That's not what we're concerned with. We want the remainder. Now, what I do with that remainder is I take it, and you might not recall this, rather than just writing R1, I'm going to write 1 over my divisor of 4, right there. So the quotient of 39,157 and 4 is 9,789 and 1/4. Okay, that would be my answer. Let's take a look at one more example right over here. 13 into 2,951. So 13 goes into 2,951. First off, 13 does not go into 2. It goes into 29 twice. 2 times 13 is 26. Subtract and you get 3. 13 goes into 35, still twice. If I subtract to get 26, if I subtract 26, I get 9. Bring down the 1. 13 goes into 91 7 times. 13 times 7 is 91. So I get a remainder of 0. So when the remainder is 0, this means that my divisor, 13, is a factor of the dividend, 2,951. In other words, 2,951 is equal to 13 times 227. And this will be, again, useful for what we're doing in algebra. Now, the idea is to take this process and extend it in a natural way to polynomials. So let's take a look. In this example, I'm dividing 4x cubed minus 4x squared minus 9x plus 11 by 2x minus 3. So I'm going to set it up the same way. 2x minus 3, and here's my division. 4x cubed minus 4x squared minus 9x plus 11. Now this will be a little bit different, of course, from what we just did with integers, because I'm now dealing with polynomials. So since I'm dividing by a binomial right here, I will look at 2 terms at a time. I will consider 2 terms at a time. If I ever am dividing by a trinomial, I will consider 3 terms at a time. But for now, it's a binomial. I will divide considering 2 terms at once. As I'm trying to make up my quotient, my answer up here, how do I figure this out? Well, what I want to do is compare the leading terms at each step. The leading term of my divisor for this problem will always be 2x. What I'm dividing into, first off, is 4x cubed minus 4x squared minus 9x plus 11. So I want to compare 2x and 4x cubed. So the question is, what do I multiply 2x by to get 4x cubed? 2x times 2x squared will give me 4x cubed. All right? So that's what I want to do. I want to multiply this binomial by 2x squared. Now, when you're doing that, if you feel comfortable just saying 2x squared times 2x minus 3 is etc., etc., feel free to do that. To keep my answer straight, to hopefully prevent myself from making any errors, I'm going to write over here 2x squared times 2x minus 3, just so I can see it. And then what do I get? 2x squared times 2x gives me 4x cubed minus 6x squared. So far this has gone very similar to what we just did up here. I figured out how many times my divisor went into the first part of my dividend and multiplied. Now the next step that follows is to subtract. So when you subtract, you're subtracting this whole expression. So that means I need to subtract 4x cubed and negative 6x squared. Subtracting negative 6x squared will make this a plus 6x squared. So when I do this, what do I get? Well, the whole idea, 4x cubed minus 4x cubed, I get 0. I'm supposed to lose my leading term at each step. Negative 4x squared plus 6x squared is 2x squared. And the next step in my division is to bring down my next term. So again, I have a binomial, and I'm looking at a binomial. Once again, I want to compare the leading terms, so 2x and 2x squared. To go from 2x to 2x squared, I multiply by x. Again, I'll make a little note to myself over here so I get this multiplication right. X times 2x minus 3 is 2x squared minus 3x. And again, what I want to do is subtract. So you can use, what I'm doing is I'm using a different pen to cover that up. You can also just use your pencil and darken it harder over that. But you need to remember to subtract and change these signs. 2x squared minus 2x squared is 0. That's what I want. Negative 9x plus 3x is negative 6x. And I bring down the plus 11. All right. So once again, I need to consider 2x and negative 6x. Well, to go from 2x to negative 6x, I must multiply by negative 3. Okay? Negative 3 times 2x minus 3 gives me negative 6x plus 9. Put this up a little bit. Now again, I've multiplied, so now I need to subtract, which will change this to a plus and this to a minus. What does that give me? Negative 6x plus 6x is 0. Positive 11 minus 9 is positive 2. All right. So I could try and keep going, but if you think about this, I would have to go from 2x to 2. I can't multiply by anything to get rid of that x, so 2x to 2 I can't do. This is going to be my remainder. So what I do with that remainder, like I showed you up here with the 1/4, is to take that remainder and write it over my divisor. Now, this is a polynomial, so I do need to write plus 2 over 2x minus 3. So this quotient right up here is my answer. So if this was on a test, you could put this right in your answer blank. The answer, the quotient of these two polynomials, is 2x squared plus x minus 3 plus 2 over 2x minus 3. Okay. I wrote that remainder as a fraction over the divisor. Okay. Now that's one example. As you do more of this, there are some tricks that can come up. The remainder must be a lower degree than the divisor. So since my divisor was a linear polynomial, my remainder had to be a constant. If I had a divisor that was, for instance, a quadratic, my remainder could be something like x minus 2. It just has to be a lower degree is the idea. Something else we need to watch out for are missing terms. Here in my divisor I had a cubic term, a quadratic term, a linear term, and a constant. So nothing was missing. In my dividend, same thing. I had a linear term and a constant, so nothing was missing. But when this does come up, we will need to correct for it somehow. If the remainder is 0, the divisor is a factor of the dividend, just as we saw up here. If I had a remainder of 0, that would mean that I could factor this polynomial. So let's take a look at a couple more examples and see how this works. All right, in the next example, this is written in fraction form, but again, we understand that fractions represent division. So what I can do is rewrite this and say x plus 3 and 3x cubed plus 5x squared minus 13x minus 2. Everything is there. From x to 3x cubed, I need a 3x squared. 3x squared times x plus 3 is 3x cubed plus 9x squared. And now what I need to do is subtract. Three x cubed minus 3x cubed is 0. 5x squared minus 9x squared is negative 4x squared. And I bring down the next term, negative 13x. From x to negative 4x squared, I have to multiply by negative 4x. So what will this give me? This gives me negative 4x squared minus 12x. Again, I subtract, which will change both of those negatives to addition. And what I see here, negative 4x squared plus 4x squared is 0. And here I get the opposite of x, and bring down the minus 2. All right, x to negative x. To do this, I have to multiply by a constant. From x to negative x, I multiply by negative 1. If I do this, what do I get? Negative x minus 3. Again, I subtract, so I change those both to plus, and I'm left with 1. I take that remainder, and I'm going to write plus 1 over x plus 3. And so this right here is my quotient. This is my answer. All right, let's keep going with another few examples. 3x to the fourth minus 7x cubed plus 19x plus 10 is going to be divided by 3x plus 2. Now here's what you have to notice. If you read through that dividend, again, what we are dividing into, 3x to the fourth minus 7x cubed, and then I go to plus 19x. In here, I am missing a 0x squared. I'm missing a term. So in order to correct this, in order to make my math work out well, I need to insert that. I need to say 3x to the fourth minus 7x cubed plus 0x squared plus 19x plus 10. If I don't do this, it will make my math get messy because things won't be aligned and I'll have to correct for it anyway. So I need to insert that 0 there. 3x to 3x to the fourth, you have to multiply by x cubed. If I do this, I get 3x to the fourth plus 2x cubed. And again, I want to subtract. So, doing that subtraction gives me 0 and negative 9x cubed. Now, I should also note right here, as I do my next part of my quotient, from 3x to negative 9x cubed, I can multiply by negative 3x squared. It's very possible for these problems to generate fractions. For instance, here if I had a 3 and here I had an 8, well, I can't do that without using a fraction. I can't multiply by 3 and end up with something like 8 without using a fraction. Those problems can come up, but we will try and avoid them. All right, negative 3x squared times 3x plus 2. What does this give me? I get negative 9x cubed minus 6x squared. Again, what I need to do is subtract. Which will change both of these negatives to plus. When I add this, well, I had that 0x squared, which again lines things up well. 0x squared plus 6x squared is 6x squared plus 19x. To go from 3x to 6x squared, I need to multiply by 2x. As you're doing this, if you feel that you don't need to write this over here to get the right answer, that's fine. Again, I just advise you to. It seems to be helpful in my experience. I need to subtract, which will change these both to subtraction, which then gives me 15x. And I bring down the plus 10. Okay? So, 3x to 15x, I need to multiply by a positive 5. Five times 3x plus 2 gives me 15x plus 10. Now again, I'm going to subtract these, but at this point you should probably realize if I have 15x plus 10 and I subtract 15x plus 10, of course, what I should get is 0. So my quotient for this problem is x cubed minus 3x squared plus 2x plus 5. Now this is interesting because what this means is we now know two factors of 3x to the fourth minus 7x cubed plus 19x plus 10. What we know is actually 3x to the fourth minus 7x cubed plus 19x plus 10 is equal to 3x plus 2 times x cubed minus 3x squared plus 2x plus 5. This is interesting to us because from an algebra standpoint, we now have the opportunity potentially to factor more. So that's part of the reason we care about division. It gives us more options, more ways of tackling factoring problems. It's one of the most useful things about it. But the remainder was 0, which means 3x plus 2 is a factor. I'll write that up here. Is a factor of the dividend. Okay. All right, let's take a look at another couple examples. Down here, I have 3x to the fourth minus 7x cubed plus 15x squared minus 65x minus 115. In this dividend right here, I go from a quartic term, cubic, quadratic, linear, constant, nothing is missing. But in my divisor, I have x squared plus 9, which is missing an x term, a linear term. So what I need to do then is rewrite this. When I do my division, I need to write x squared plus 0x plus 9 divided into 3x to the fourth minus 7x cubed plus 15x squared minus 65x minus 115. And I probably should have given myself a tiny bit more room there. Since this is a trinomial, I will be looking at 3 terms at a time, but still, as I match it up, I'm only looking at the leading terms. From x squared to 3x to the fourth, I need to multiply by 3x squared. So if I do this, 3x squared times x squared plus 0x plus 9 will give me 3x to the fourth plus 0x cubed plus 27x squared. And again, what I want to do is subtract. So I will do just that. Three x to the fourth minus 3x to the fourth is 0. Negative 7x cubed minus 0x cubed is negative 7x cubed. Here I get negative 12x squared. And I bring down my next term, negative 65x. Okay? Again, x squared to negative 7x cubed, I need a negative 7x. Find my product. Negative 7x times 0 gives me 0x squared. Negative 7x times 9 gives me negative 63x. Now again here, make sure you're subtracting, otherwise your numbers get much larger and well, you get very far off the mark. 0, negative 12x squared, and here I will get negative 2x. And I bring down my last term. Negative 12x squared minus 2x minus 115. To go from x squared to negative 12x squared, I need to multiply by negative 12. So I will do just that. Twelve times 9 is 108. And I subtract. I get 0, I get negative 2x, and here I will have negative 7. So what I do is I take that remainder and I put it over my divisor which was x squared plus 9. Now I can leave my answer like that. It's also possible to factor a negative from the numerator and write this as 3x squared minus 7x minus 12 minus, and then on the numerator, since I am factoring out a negative, I would actually have 2x plus 7. Now that can get a little tricky and it's a little bit easier to mess up. So we can just leave it like this just for clarity's sake. I'm going to write that a bit larger just to make sure you can read exactly what my answer is. My quotient is 3x squared minus 7x minus 12 plus negative 2x minus 7 over x squared plus 9. Or again, as I said, minus 2x plus 7 over x squared plus 9. If you feel comfortable writing it like this, that's fine. If not, this is also perfectly acceptable for our standards.